Hello guys, welcome back to the quantity surveying workshop and to another video. In this video we're going to be continuing our measurement for the quantities for retaining walls, and we're going to be using this video to finish everything concerning retaining walls. So in this video we're going to be measuring the concrete ancillaries. What do we mean by concrete ancillaries? These are all the materials needed before we can cast our concrete, and one of them is formwork. So we're going to be using these videos to finish everything concerning retaining wall. We're going to be measuring the formwork, the whip holes, and the ashes. Those are the items that are left. Now remember that this retaining wall is mass concrete, not reinforced concrete. When the structure you're working with is reinforced concrete, then you know that you're also going to measure for the tonnage of the reinforcement used for the structure. So when we want to measure for our formwork, now let me just use this drawing as an example. When you want to measure for your formwork, right, you know that you're going to be placing the formwork in such a way that we need to get a form for this trapezium structure on top. As for the one underground, which is the base, the trench is going to give the base of this retaining wall its form. So there is no need for formwork, except where the soil is not stable. So you might have to add spread and then create a formwork that will form the shape of the base of the retaining wall. So we're assuming that the soil is stable. So since the soil is stable, now after digging our trench, now it means that it will be able to give us the form of the base of the retaining wall. But what can we do now to get the form for the wall and the piers? We're going to be using formwork. Now if you look at this is not a conventional rectangle or square that where the formwork will be easy to make. Now you can see that this is a trapezium. So how are we going to go about getting the formwork for this trapezium? Now if you look at this drawing here, you can see that this is a slanting side, right? Now we're going to be providing formwork for this slanting side throughout the entire length of the retaining wall. Also, we're going to be providing formwork for this side, this straight part of the retaining wall. Let's just isolate the piers for now. So now this part here, like the spaces in between the piers, we're going to be placing formwork there. Then we're not going to be placing formwork for these piers here at each side. That's this side, and the side that you cannot see, right? So that is the method we're going to go about capturing for the formwork for our retaining wall. Now another thing you need to have in mind is what kind of formwork are you going to be using. Now you know that the type of formwork that you use will determine the kind of finish that the structure would get. So you have to put that in mind. Now in our SMN, they say that when it comes to formwork, there are two approaches. You are either placing formwork for rough finish, or you are placing formwork for fair finish. So now how do we know which one is which? Now let's go to our section. Now the reason why we need to determine which one is which is because of procurement, right? Fair finish is more expensive than rough finish. What I mean by rough finish is mean that after casting there's no need to do finishing to make it smooth. That's what rough finish is. Then fair finish means that you want it to look smooth and presentable to the viewers, right? So now which side of the retaining wall are we going to be doing fair finish, and which side of the retaining wall are we going to be doing rough finish? Now if you look at this drawing, you can see that this is where the soil is going to be retained. So if soil is going to be retained at this side, which is the straight side of the retaining wall, it means that viewers or an individual or a passerby would not see this part of the retaining wall because it is already covered by soil. However, this side of the retaining wall is open, so it means that human eye can see this side. That's the slanting side. So now since human eye can see the slanting side, it means that we can do fair finish here so that it can be appealing to the viewers. While for this straight side here, which is covered by the soil, there will be no need to do fair finish here. Because what's the essence of doing fair finish for aesthetics when you're still going to cover soil on it? So this will be rough finish, the straight side, and then this will be what? Slanting finish. I hope that is understood. So the first thing we're going to be doing is to try to determine the area. Remember, formwork is measured in meters square. The area of this formwork that will be laid at this slanting side throughout the entire length of the retaining wall. I hope that makes sense. So how do we go about determining what is the length? Remember, area is measured length times breadth. So we know that the total length of our retaining wall is what? 30 meters, right? So it means that the length of the formwork is going to be as long as the length of the retaining wall, which is 30 meters. So we need to look for the other parameter, which is the parameter of the slanting side, which will give us the breadth of the formwork. So how do we get the breadth of this formwork? Now, since we know that it is slanting, we are going to be using Pythagoras theorem. So now when I mean by Pythagoras theorem is for triangles, right? But this is a trapezium. So what we'll do now is to cut this trapezium, cut out the triangular side of this trapezium. So when we cut out the triangular side of this trapezium, we can get the length for the base, and we can get the length of the height of the triangle. So now we know that if we cut this, let me just use this thing like this. Now you can see the triangle, right? If we cut the trapezium and we get this triangle, what is the height of this triangle from here to here? It will be the height of the wall, as you can see in this dimension here. In this dimension here, 4 meters, right? Now, what would be the base of the right angle triangle? They've told us that from this point to this point of the wall is 1,200, and from this point to this point is 0.30. So 1.20 minus 0.30 is 0.90, meaning that the length of this base from this point of the triangle to this point of the right angle triangle is 0.90. So you see we've gotten the parameters. Now what we need to determine is the hypotenuse. I hope that makes sense. So now let's go and measure. So now, as you can see, we're starting with our formwork for the sloping side of the retaining wall, right? So now we brought out the triangle, and we calculated that the height of the right angle triangle will be the height of the retaining wall, which is 4.0, and the base of the right angle triangle, which we calculated for, is 0.90. So now we need to determine what is the hypotenuse side. So we're going to be saying using Pythagoras theorem. So using Pythagoras theorem, we will now say, Pythagoras theorem is hypotenuse square is equal to the sum of the square of the two other sides. So, which is L square is equal to 0.90 square plus 4.0 square. So L square will now be equals to 0.81 plus 16. So L square will now be equals to 16.81. So 16.81 is L square, but we are looking for L, not L square. So L will now be equals to square root of 16.81. Therefore L will now be equals to 4.1 meters. So it means that the length for the other parameter of the formwork will be 4.1 meters. So we'll now go to our SMM to determine what our description would be.
So to determine the description for our formwork, now the formwork we are trying to describe is the formwork for the slanting side of the wall, right? Now at this point you have to ask yourself, where is the point where viewers are going to be seen, right? So you can see that in the drawing, the slanting side is the part where viewers are going to be seen, while the other side of the retaining wall has been covered with soil. So you will now ask yourself, which of this side of the retaining wall are we going to be using smooth finish, and which of this side of the retaining wall are we going to be using rough finish? So the place where viewers are going to be seeing, like where, for example, you see a retaining wall, you want the place where you are going to be seeing, that's the face where you are going to be seeing, to be smooth, at least aesthetically pleasing, while the other side where the soil is going to be retained, there is no need for smooth finishing there, because it is going to be covered back by soil. Now remember that your choice in when it comes to building construction has cost implications. So smooth finishing will require higher cost than rough finish. That is why you have to specify. So when it comes to the formwork, we need formwork which will be able to give us a smooth finish. Now if you look at this, for the slanting side, which is the side where the viewers will be seeing, we are going to be using a formwork that will give us a smooth finish. So if you look at this now, they say that under concrete ancillaries we have formwork, right? And they say that our formwork can either be measured in linear meters or in meters square. It is measured in linear meters when the width is not exceeding 0.1 meters, or when the width is between 0.1 to 0.2 meters, as you can see in our third division. And they say it is above, it is measured in meters square if the width is between 0.2 to 0.4 meters, 0.4 to 1.22 meters, and exceeding 1.22 meters. So now you can see they've given us different kinds of formwork in our first division. They see formwork for rough finish. So we're going to be using this one when we're trying to describe the formwork that will be used for the retaining wall at the back where the soil will be retained. Now, but for in this case, which is the slanting side, we are going to be using fair finish, which is formwork that would make the concrete to be smooth after the concrete has set. So we are going to be saying our description is formwork fair finish. So our second division now is trying to tell us what plane is the formwork. Is the formwork vertical? Will it be placed vertically, horizontally, or sloping? Now the formwork that we're trying to describe is a sloping side of the retaining wall. So it means that our formwork will be sloping. So we're going to be saying plane sloping, which is number 2. And then the third division will now tell us whether what is the width of our formwork. So as you can see, we've already calculated that the width of our formwork is 4.1 meters. So it is exceeding 1.22 meters. So we're going to be using section 5 of our third division. So basically our description for the slanting formwork will be formwork fair finish, plane sloping, and width exceeding 1.22 meters. So that is what we are going to be describing for the sloping formwork.
So from our SMA, we've stated that we are going to be having formwork fair finish. I've already explained why we're using fair finish for the slanting side. Fair finish, plane sloping. Now this plane sloping is because of the plane of the formwork is slanting. So exceeding 1.22 meters. It is exceeding 1.22 meters because our slanting side is 4.1 meters. So we're now going to measure. So formwork is measured in meters square. We know that the parameters will be length times breadth. The length will be the total length of the retaining wall, which is 30 meters, and then the other parameter, which is the breadth, will be the slanting side of the formwork, which is 4.1 meters, and then you close. So when you do the math, 30 times 4.1, they are going to be having 123 square meters. So doing this, we've measured for the slanting side, the formwork for the slanting side of our retaining wall. So next we'll now do for the straight side of the retaining wall. So now if you look at this straight side of the retaining wall, right, we want to determine the formwork. Now you can see that the straight side is intersected by piers. You can see we have piers here, and they told us that the piers are at 5 meters center to center. So it means that first 5 meters will have a pier, next 5 meters another pier, next 5 meters another pier centrally placed. So now, how do we now determine the formwork that we're going to be placing at this side? So this is what we're going to be doing. First, we're going to isolate the piers. So if you isolate the piers, what are we going to be having? We're going to be having the straight side in between each piers. I hope that makes sense. So now, how do we determine the total length of those parts in between the piers? How can we calculate that? Now we can calculate that by doing this. Since we know that this area is going to span throughout the retaining wall, what we can do is this. We know that the total length of our retaining wall is 30 meters. So if from here, this point to the end point is 30 meters, we can now remove the number of piers at this side. So now we know that this portion of the pier is it told us that is 0.75. So if from here to here 0.75, we can now multiply it by the number of piers that we have spanning throughout the wall, and we've already done that calculation before. So if we look at this, when we're calculating it, we said that we have 7 number of piers. So what we can now do is this. Since we know that the number of piers are 7 in number, and that this part that is along the length of the retaining wall is 0.75 meters, we can now multiply 0.75 by 7, and it will give us the total length of this part of each of the piers spanning along the retaining wall. So now when we now do that, we can now minus it by the total length of the retaining wall. Whatever we have is the summation of each of the lengths of this portion of the retaining wall that is in between the piers. So with this now we're going to be measuring. So for the straight side, like I said before, we need to determine what is the summation of each of these lengths here in between the piers, this portion here, until we get to the end. Now, how do we do that? We know that the total length of our retaining wall is 30 meters, right? Good. Since we know that the total length of our retaining wall is 30 meters, we are now going to less the length of all the piers within that 30 meters. So now we know that less piers length, right? So now we know that the number of piers are how many in number? 7 in number, and we know that the length of the pier is 0.75. So now when you do the math, 7 times 0.75 is 5.25. So it means that the summation of all the lengths of the piers is 5.25. So now to get the length of the area that we need, which is this portion here, this portion, and so on and so forth till it gets to the end, we have to minus these two parameters together. So 13 minus 5.25 is 24.75, meaning that the total length that we're going to be needing formwork for the straight side, excluding the piers, that's the length from here to here, from here to here, and so on and so forth till we get to the end, is 24.75. So now we know that formwork is measured in what? Meters square. So we've gotten our what? Length, and now we need to determine what is the height of the what? Tire at the straight side. So now we know that from here to here is what? The length, the height of the what? Wall for the retaining wall. And if you look at our section here, they've told us that the height is what? 4 meters. So it means that from here to here would be what? 4 meters. From here to here would be what? 4 meters. So we've gotten all our parameters. Now we can now what? Book. So like I said before, the straight side is the side that is going to be retaining the wall. So what kind of formwork are we going to be using? Formwork for what? Rough finish. So we can now describe by saying what? Formwork rough finish. Plain vertical exceeding what? 1.22 meters. So this is what our SMM has told us our description would be. So now we can now what? Measure. So our length for the portion of the straight side of the retaining wall is what? 24.75. So 24.75. And what is the other parameter? The other parameter will be the height of the retaining wall, which is what? 4.00. So when you do the math, 24.75 times 4.00 is equal to what? 99.00 square meters. So doing this, we've measured for what? The formwork for the slanting side and for this portion in between what? The tires. So now the next formwork we're going to be looking at will be for the formwork that would hold the concrete for the what? Piers. So now, how do we measure that now? We're going to be using something similar to what we just did now. So now, let's look at this edge here. This edge of the formwork. So now to determine the area of formwork that we're going to be using to place at this side, we need the length and we need what? The breadth. So what is the length from here to here? The length from here to here is what? The height of the what? Wall for the retaining wall, right? So now we know that the height is what? 4 meters. So we've gotten our first parameter. From here to here is 4 meters. And then what is from here to here, which will be the second parameter, which is the breadth. Now if you look at our section here, what can you see? This is our pier here. So the protrusion says it is what? 0.30 meters out. Similarly, if you look at the plan here, you can see that this is the protrusion of the pier and it is what? 0.30 meters. So with this now, we've gotten our two parameters. So we can now what? Describe. So what kind of formwork are we going to be using for that pier? Now remember, the piers are attached to the side where soil is going to be retained, meaning that we're going to be using what? Rough finish. So our SMM states that the formwork for the piers now would be what? Formwork rough finish plain vertical, because it is straight vertically, and then the width is what? 0.2 to 0.40 meters. Why? Because the width is what? 0.30, so it's in between 0.2 to 0.4. So now we'll now what? Record 0.30 by what? 4.00. Now this is for one side. Now remember that the formwork is for what? If you look at the plan here, the formwork is for this edge and for what? This edge. So we'll multiply it by 2. So multiply it by 2 and then multiply by the number of piers that we what? Have, which is what? 7 in number. I hope that makes sense. So this is the area for one side of the edge of the protrusion for that pile. I'm multiplying it by 2 because we're going to be cutting for the two sides. So this is for one pile, but we have 7 piles, so we'll multiply it by what? 7. So when you do the maths now, what are we going to be having? 0.30 times 4.00. We're going to be having what? 1.20. So 1.20 is the area of formwork we're going to be needing for one pile for the two sides. Then multiply by what? 7. We're going to be having what? 8.40 square meters. So 8.40 square meters is the area of formwork that we are going to be needing for the two sides of each of the piles, for the 7 number of piles that we have in our what? Drawing. So next now will be for this side of the piles. For this side of the piles, we've done for the edges, that's for the sides. Now we need to do for this front side, which is what? 0.75 meters long. So if you look at this elevation here, we want to do formwork for this side here. I hope you can see that formwork for this side here. So we need 2 parameters, the length and the breadth. So we know that the length from here to here will be as long as the wall, which is 4 meters, and they told us that from here to here is what? 0.75 meters. So we've gotten our what? Parameter. Now we need to what? Describe. So since this is also formwork for the piles, instead of remeasuring everything, we're going to be saying what? Ditto, because it's the same work item. It is formwork and it's also for what? The piles. It's just that the only difference is a different side of the pile. So we'll now say ditto width 0.40 to what? 1.22 meters. Why? Because the width is what? 0.75, which is in between 0.40 and 1.22 meters. So we'll now what? Measure. So we've already gotten our parameters as what? 0.75 by what? 4.00 meters. So this will be the measurement for the area of one side or one pile. But we have how many piles? 7 in number. So we'll multiply by what? 7, and then we'll close. So when you do the maths, 0.75 times 4 is equal to what? 8 is equal to what? 3.00 square meters, which will be the area for one side of that part of the pile. But we have 7 piles, so multiply by 7, we'll have what? 21 square meters. So we'll be needing a formwork of 21 square meters to cater for what? That front side of the pile. So doing this, we've measured for what? All the formworks for our what? Piles. Then we'll now what? Close. So next thing we're going to be measuring will be the whip holes, and that is easy. The whip holes is enumerated, meaning that it is in number. So you just describe the kind of whip holes you have in the retaining wall, and then count the number of whip holes that you have. So if you look at this our section here, you can see that this dotted line coming like this, they've said that it is what? 100 mm whip holes, and they are found at what? 1.8 meters center to center, meaning that throughout the 30 meters length of the retaining wall, we are going to be seeing whip holes every 1.8 meters center towards center. So now with that information, we can now use it to determine the number of whip holes that we have. And how do we do that? We know that the total length of our retaining wall is what? 30 meters. We'll divide this by the word center to center spacing to get our number. So we can now do the calculation. So we can now say number of whip holes at what? 1.8 meters center towards center. We know that the total length of our retaining wall is what? 30 meters. So divided by the word center to center dimension, which is what? 1.80. And when you do the maths, we are going to be having what? 30 divided by 1.8 is 16, right? Is 16.67, which is approximately what? 17. So 17 plus 1 is equal to what? 18 number. So we're going to be having what? 18 number of what? Whip holes. I hope you understand. So now we're not going to what? Describe. So we'll describe by describing the kind of whip holes that we have, or the kind of pipe that we have to create the what? Whip holes. We will now go to our BSMN to see what our description would look like.
So to get the description for our whip holes is going to be found still under concrete ancillaries, and they are under what? Inserts. So you can see that it can either be measured in meters or in what? Number. So they say that if it is linear insert, it is measured in meters. If they are other inserts, then it is in number, so they are enumerated. So the kind of inserts we're looking at here are other inserts, pipe, right? That is what we're looking at here. So they say that the item description for insert shall be identified as the components to be cast or grouted and sites, and states their principal dimensions. And also, since it is in number, right, all you need to do now is to give a description of the kind of insert.
So I said that in our standard method of measurement, they said that we should just describe the kind of whip holes that was used, the diameter of the pipe, and so on and so forth, and then we'll now measure the number that we've already was calculated for. So we can now say, you can just say, let's say concrete ancillaries, which is the work item we're looking at, then describe the kind of pipe, 100 mm diameter, clay wire pipe. So let's just say lounge drain, inserts, accessories. So you can see concrete ancillaries, 100 mm diameter clay wire lounge drain insert ancillaries. So doing this, we've what described for our what whip holes, and they said that how many in number. We've counted what 18 in number. So 18 number, and then we'll close. You can either do 18 in number, or you can do 1 multiplied by what 18. It also goes. So doing this, we've measured for our what whip holes. So I hope you understand the process for measuring the whip holes, so straight to the point and easy to calculate. So the next work item and the last work item we're going to be doing for concrete ancillaries is our what ashes. So if you look at this section now, you can see that they've told us that this here is our what ashes, right? So now how do we measure for these ashes? Now they've told us that this is what the description: continuous pocket of ashes between piers, 0.45 meters what thick. Now they told us that these ashes, now from what we've seen there, they told us that the ashes will be found in between what the piers. Good. So now look at this. If you look at our section now, they say that in between the piers we'll be finding what ashes. So if you look at this red barrel, I've used it to demarcate the placement of the ashes. So we're going to be having ash at this side. We're also going to be having ash at this side. We're also going to be having ash at this side, continuous till we get to the other end of the what retaining wall. I hope that's easily understood. So now, to determine this ash, to determine the measurements for these ashes, it is going to be measured in what volume, meter cube, meaning that we're needing 3 parameters: the length, the width, and the what thickness. Now, if you look at this, if you remember when we're calculating for formwork, for the straight side of this retaining wall, you can see that the ashes are also placed within that area that we've what calculated for the straight side. So instead of determining the length of these ashes again, just go back and what collect that measurement that we've collected, that we've calculated for the length of what this portion of the retaining wall in between the piers. That's this portion here, then the next portion, then the next portion, and so on and so forth. So when you get that parameters, it means that you've gotten the first parameter, which is the parameter of what the total length at which this ashes is going to be poured in between what the piers. So next things that we're going to be looking for would be how wide the ashes will be poured. So if you look at our section so that you can see it easily, this is the width from here to here. They've not given us any parameter. We can calculate for it. So the second parameter will be what? To determine the width from here to here. Then the third parameter is the what? Thickness, which they told us is 0.5 meters what? Thick. I hope you understand. So now, what is the total length at which these ashes will be what? Poured. All we need to do now is to go to the formwork that we've what? Measured. So if you look at this here, you can see that they told us that the formwork at the length of the formwork at that side where the ashes will be poured was what? 24.75. It means that the length at which these ashes will be poured in between the piers will be what? 24.75. I hope that makes sense. So what we're going to be looking for now would be how wide will the ashes be poured. As you can see in this drawing, we need to determine how wide from here down to this end that the ashes will be poured. So how do we determine that? Now if you look at this, the ashes started from what? The edge of the wall and ended at the other side of this base. Now they told us that from here, let me just go up a little. They told us that from here to here is what? 2.4 meters. And they told us that the wall from here to here is 1.2 meters. So 2.4 meters minus 1.2 meters, whatever we get, we'll divide it by 2, which will catch up from here to here and from here to here. So all we need to do now is to pick one. So from here to here, you can see it is parallel to the width of the ashes, which is from here to here. I don't know if that makes sense. So doing that, whatever we get will be the width of our ashes that we have here. But you can see that it is parallel to the what? Spread of this what? Base for the retaining wall. So all we just need to do is like determine what is the spread here. You can see that the wall is centrally placed on the base. So now if you can remove the wall from the length of the base, divide it by 2 because it's centrally placed. So what we have there will be equal to what we have here. I don't know if that makes sense. So now with that, we can now what? Calculate. So first things first, we know that the length of the ashes is the same as what we've calculated for our formwork, which is what? 24.75. So if you want to recalculate, you can also recalculate, because in measurements, the more waste calculation you do, the more you get scores in your examination. But I want to go straight to the point. So length of the ashes is what? 24.75. Then we want to determine what the width will be. So like I said before, we know that the width for the base of the retaining wall is what? 2.40. Or now less what? The thickness of the wall, which is what? 1.20. So when you do the maths, you're going to be having what? 1.20. So divided by 2, it means that one spread is what? 0.60. So what this means is that from here to here is 0.60, and from here to here is 0.60. So you have to pick one. So you can now what? Describe, since you've gotten on our parameters, the length, the width, and the what? Thickness. So we'll now describe by saying what? Ashes in continuous what? Pockets. In continuous pockets behind wall. in between what piers. So we can now what measure. So the first parameter is what 24.75. The second parameter is what the width, which is 0.60, and the last parameter is what thickness, which they told us is what 0.45 meters thick. So when you do the math, 24.75 times 0.60 times 0.45 is equal to what? 6.68. So 6.68 is the total volume of ashes that we're going to be needing for our what? Retaining wall. So doing this, we've measured for all the quantities needed for our retaining wall. I want to use this opportunity to plead with you guys to assist us by joining our membership. Our membership has two tiers: the support tier and the masterclass tier. So the support tier is for viewers that would like to support the channel by paying a little fee, and the masterclass are for viewers who would like to get more difficult measurements, both civil engineering and building related. So you can build up your measuring skills by advancing your knowledge to what you have by joining our membership. I am also going to be making another video strictly for members only, still on retaining walls, right? But the only difference is that the design is more complex than what we've had here. And in the concrete work, when it comes to the placing of concrete, remember I told you that we place our concrete in what stages. So this one we only did 2 stages, but in the one I'm going to be doing for strictly members, it will be 4 stages, and that is more difficult. So you can see that we're not here to play. So please join the membership. Thank you, and I will see you in the next video.